Evening gents, this is going to be an overview of the material, last couple of bits of material required for the exam. So thus begins my rambling. The specification, you should have access to this already. You should be able to see. And as you can see from the outcome content here, 1 and 2 is what's going to be covered in the exam. 3 and 4 down here is what was covered within the coursework. Okay, so we're looking to look at the application range of mechatronic systems and electromechanical models and components of mechatronic systems and products to do with first and second order systems, analogies, and sensor and actuator technologies within mechatronic systems. In case you weren't aware, the exam is worth 50% of your overall grade. It's a 2-hour written exam. There's 10 questions in this particular one, covering the range of the outcome content there of 1 to 2. So as I was saying earlier on in the class, your exam is mainly going to be based around the first 3 folders, and the rest is it was used for coursework. Within the folders there is, well, more information is really required for both coursework and for exam. So don't be put off by the sheer amount of, especially some extra PDFs which are chaptered out of certain textbooks, which I find useful for creating some of the notes and good for background reading if you have extra time on your hands. So I did go over last time about reliability, unreliability, availability and unavailability. The notes were based out of the Reliability Prediction Basics PDF, along with one of the textbooks within mechatronics and also a textbook within measurement systems, and also a good PDF there is the probabilistic R&M parameters PDF. But the one we're going to look at now for a few seconds is Reliability Prediction Basics. So making sure that when you're looking at this particular one that you're familiar with the main terms, what availability, unavailability is, reliability and unreliability, be able to define them, be able to quote the formula. Now within the actual exam you are going to be required to do some maths calculations. They are based around reliability. They're also based around T-lock, which comes near the end of this section, which we done an example 1 last time. You're not going to be given that many formulas. You do need to remember some of them. You are given 2 formulas in relation to the reliability, which they're not going to be disclosed, but needless to say, you will need to know more than what's provided. So make sure you are familiar with this one. There's not a terrible lot of formulas really to learn, and they're really straightforward once you understand what the terminology is of them. They're quite straightforward. They're sort of common sense in a way. So have a look at especially this PowerPoint. There's also another one there. This is only 9 pages. Pardon me. This is only 9 pages and quite concisely wraps up some of the formula, where they're derived from, how to rearrange in some instances which might be required. Talks about the bathtub curve, which we talked about last time as well. Also talks about redundancy, different methods of putting it in place, the reasons behind it, etc. and so on. One of the main texts, however, will be from, if I go back to this window, number 11, the reliability of measurement systems. So that is from the textbook I was speaking about a few seconds ago. It's a chapter out of it on reliability, choice and economics of measurement systems. It's run through some of the main aspects again of how you derived some of the formulas, and again you're not going to need to know how the formulas came about. So some of the stuff in the actual text is a little over detailed for what we require within the exam and within the unit generally, but you do need to know where they came from, just for your own knowledge, so you know why they're being used, and the formulas themselves. I'm not necessarily saying you need to know each and every single one of the formulas on this particular one, but being able to show where they came from, just from an understanding point of view, to help you in some of the questions. So as you can see, as you scroll down through, you can get all the different types, failure rates, and so on. Just being able to understand each of them. Now there's some of them there that you see the derivation of them has come from either integration or differentiation to derive an answer. You're not going to be asked within the exam to do that. The maths within the exam is basic enough level maths. You need to obviously be able to understand the terms that you're working with and be able to be comfortable with rearranging some formulas and applying formulas to set values to derive other values to then get a final answer from a different calculation. But it's nothing that is a stretch beyond level 4 mathematics at all. So don't be worrying too much that some of the derivations of the formula within here seem overly complicated. The ones within the exam are nowhere near what you're seeing in here. All you're doing is applying the final formula that is provided within this document to a question to gain an answer. So it's just the application of the final formula, as I said. So this, as I say, for this particular document is where a lot of the notes were made from, but I say it goes far well and beyond what we actually need. But it is good for down near the end here that it does have design and maintenance for reliability. Being able to know why some of these terms are used and what they're basically used for within the measurement system would be useful for your exam. And the choice of measurement system isn't really applicable to us, so just see anything else in this document. There's nothing really, honestly, within that particular one that is useful to us for the exam. Okay, back with the T-lock example. We covered it in a wee bit more detail, but I'm just stressing again, this is one of the things that is going to be coming up. And just to also, as reference, I think it was Blair, you spotted I had made a wee copy and paste error somewhere along the lines, where this here value was 2000 previously. It should have been 3000 as it is now. I'm just going to fix the actual text color back into the purple. So making sure that you're able to do T-lock examples and also that you know what the formula is. The example here only provides data that is actually required. It's not necessarily going to say that the data you're provided with is all needed for the formula, so don't be getting mixed up with what you're provided with and what the calculation is required. So you may be provided with extra information here that is not required within the formula, so you need to know what the formula is. If that doesn't give it away enough that you're not going to be provided with the T-lock one, pay attention now. So T-lock, as I say, make sure you look over it, know the formula, know how to apply it. Okay, so I've opened up number 1 from the folder number 3, which is the Sensor Technologies document, the Word document. Again, don't be overly panicked because of the size of the document or the amount of information on it. You're mainly going to be looking to be able to apply base knowledge about sensors and actuators and be provided with enough information and formula to be able to carry out simple calculations around certain situations. So don't be overly panicked. You do not need to remember and revise the formulas within here. You're not going to be required to use those within the exam without them being provided for you. There are other wee typical examples. If you can look at some of the ones and why sensors, why actuators are used, would be a good background reading for the exam as well. So again, have a quick browse over, make sure you're familiar with the operation of each of the type of them in case you're needing to actually describe the operation of them, either sensors or actuators, just roughly. We're not talking in-depth technical knowledge, but we are saying that if you're asked how, for instance, what's the one there, an absolute encoder works, you should have an idea on how to put 5-6 sentences together on exactly how it works. Next up is measurement systems. There's going to be a couple of questions based around measurement systems, and this here is number 4, measurement systems.docs, and it's off the same folder again that we were just previously talking about. It's a very brief overview of what measurement systems are, the anatomy of a measurement system, and these are some of the things of recall information that you could be asked to be sort of provided with within the exam. So make sure you understand the systems, all the system elements of a measurement system, you know the purposes behind them, and you know various items that could be used in each of the elements. So there's a separate one that I'll load up now. I believe it's in near the end of this particular one. So this is number 3, measurement systems introduction, and again it covers some of the bits there that we're talking about. There's an example on this particular one's an electronic weighing scale, shows you the 4 elements, possible components, and basically what each of the components does. There's then an overview of what a measurement system is, definition, block diagram representation, system anatomy, which is covered in the one we were just at. And here there's the bit I was relating to being able to identify types of actuators, or rather sensor parts, elements, and where they would fall either within sensing, signal conditioning, signal processing, or data presentation within a measurement system. So being able to recognize, where would the thermocouple come within each of the 4 elements, for instance. There is then also this particular document, which is number 5, sensors. It goes on to give numerous actual examples of different types of sensors, along with the characteristics and a brief overview of them. Now, we're not again asking you to be able to rhyme every single one of these off, but you should be able to realize that if you're given, for instance, a bellows sensing element, which is sort of a giveaway that has the word sensing in it, but if you have any particular one of these, like pilot tubes, you'll be able to recognize that it is part of the sensing element rather than data presentation, for instance. Being able to recognize the different segments. So make sure you have a good overview of each of number 5, sensors, 6, 7, and 8, data processing, and so on. Each one of those, that you will be able to recognize which part of the 4-section element of a measurement system that each might fall into. On to the next area of the exam, which covers a little bit to do with mathematical modelling. Within this, there's sort of 2 elements. There's a modelling tutorial, which is one of the main documents here. If I get this loaded up. So within this particular document, which is a modelling tutorial, this gives you a pretty good quick overview of basically all the terminology within it, how you derive some elements, and basically the process behind what's happened within electromechanical models. So read through, especially the first couple of pages of this, just to see what the block elements are on about within each section, and how they're represented. For instance, in many cases we define the transfer function as G. So just making sure you understand the terminology and the symbolism used within each one of them. And again, just to stress, don't be letting the amount of formula or notes within this one section freak you out. You only need to have an appreciation of what the transfer function is and how it's used within each system. So don't be worrying too much about each of these. Just have a quick read through, practice 1 or 2 of the questions so you're somewhat comfortable with each one and how they're applied to a given situation. Actually, if you just hop back to the instrumentation, or rather folder 3, the measurement systems, the bit I was looking for the PDF is Instrumentation and Control, Icon 1. So this is a PDF from, I think it's Free Study, based on the old HMCD unit that we actually never delivered, but we did use some of the notes from it in previous years. Instrumentation and Control was the unit name, which lends itself well to a small section of what we do within mechatronics. But in here there are further examples of transfer functions and doing modelling, which I'll say that one of your questions within the exam is based around one of the examples, and I'm not saying it is the same, it is based around. So if you're able to complete all of the elements within this particular PDF, this outcome one or whatever it is. And just down at the end of this particular document, there's also good definitions and explanations pretty much of some of the different things you're going to encounter within measurement systems, like range, accuracy, repeatability, that you might be required to rhyme off a short description of. So some of the ones down here are pretty good, being able to know the difference between range error and zero error, whether you're going to affect just the offset or the gradient, which is the difference between the modifying input and the interfering input. Also down here you've got the examples of hysteresis and non-linearity errors, or linearity errors, which is obviously non-linearity. A couple of examples as well. As I say, all of these are pretty basic maths, and most of the stuff you will be supplied with in relation to this type of thing. If you're not supplied with it, then you're just figuring things out from what you already have. So it's nothing beyond you in the maths sense of things. Don't be worrying too much that way. If you're able to work through this document and be relatively happy with everything that's going on, have an attempt at being able to define each of those elements that you're seeing going across your screen now, and you'll be well suited for those, or one question, or one or two, I forget how many, within that section. Actually, yeah, the other one point then I wanted to draw your attention to is there's one final document which is found, if I hop back to it here, under models, 042 springs and capacitors. I have it open over here already. It's a wee fact sheet that is only 2 pages long. Please make yourself aware of everything that is going on within it. Read over, be able to quote formula from it. There's not too many actually on it. There are also typical exam questions and answers on here, and if you can remember how lazy I can be in creating exam questions, you might be alright with what you're doing within this one sheet. So make sure you are understanding the analogy between the physically different elements, but have still a lot of similarities in their math, and what we're talking about here is obviously springs and capacitors and how similar they are math-wise, despite being physically completely different in what they do. So make yourself well familiar with each of those charts and everything as well, and typical exam questions and answers too. Okay. And finally, to finish off the last little element, under folder 1, the intro to mechatronics systems, definitions of mechatronics, the various systems, and just being able to basically have an appreciation of the benefits that mechatronics is able to provide if you're using systems together with one another. So the integration of systems, why designing from scratch using mechatronics is more beneficial than using the standard concurrent design method. You'll also be looking to be able to describe advantages and disadvantages of designing systems from scratch that are mechatronic in their nature, both for single products or products that are going to be linked together as in integrated, and also leading on from that, basically also be able to define what mechatronics is in relation to manufacturing of both consumer and industrial products, and also mechatronics as a design philosophy. So I think that's pretty much us finished covering all the elements. To say, be familiar in number 1 with what mechatronics is, being able to define it, the advantages that it provides. Within models, you're going to need to know this 2-page document, look and have an appreciation of the modeling tutorial, and there's also other background information reading if you so wish. Within number 3, sensor and actuator technologies, be able to identify which of these fall under which section of a measurement system. Measurement systems introduction, be able to define the areas, know the areas Sensors know and have an appreciation of different types of sensor and what they might be used for, what they might sense. Same thing goes for signal conditioning, processing and data presentation. Know the different elements that could possibly make it up, and nothing outside of the notes is going to be found, obviously within the exam. Characteristics of a measurement system, reliability, the PDF on reliability and the T-log example make up a couple of questions and provide quite a lot of marks for your exam. So make sure you have a good overview of from 9 to 12 and a pretty good appreciation really of from 1 to, where does it go to, 8. And other background information of PDFs of the reliability prediction basics, the probabilistic R&M, parameters, and other ones are more detailed chapters of books that aren't really critical, but again they're just there for extra information. And that's pretty much it. Your exam is based on those 3. The other ones down here, 4, 5, 6 and 7, was all on your coursework. So 50%, 2 hours, 10 questions. What I would say is that when this was being internally moderated, which David Russell was doing, with him looking at it without knowing the content, had a quick guess at roughly how long each of the stuff would require within the exam would take, and he came out with a guess of initially 125 minutes. Now I wouldn't particularly agree with some of the minutes that he put against 1 or 2 of the questions. I thought were a little bit long, but if his estimation for a student was 125 minutes, which is actually 5 minutes over your time, do be aware that this could be tight for time, but looking, or once you do see the exam and looking at what needs to be covered within the 2 outcomes, you'll see that there's nothing really that can be removed within it, and I've thrown in a few maths ones to make sure that they can go quite quickly as long as you obviously know what you're doing. Just on the maths one again, don't need to know too many formulas except the one to do with the models that I was telling you about, so being able to quote from that there particular one. And then you're going to need to know basically the ones from the reliability, and I'm not saying all of them. You need to know, they're going to give you some data basically, and you're going to need to realize what type of formula you need. 2 of them are provided within the question, so don't be too alarmed. You should be able to get a fair distance into the question even if you can't get all of it done, if you're forgetting one. But that's pretty much it. Please do email if you have any questions whatsoever to do with the exam, and apart from that, fellas, all the best for Monday, and maybe depending on the time frame I might actually be able to nip along and see you as you finish. But other than that, all the best again with the exam, and hope to see you sometime soon. Alright, all the best, bye.